Alright, just another really quick video. Do a couple of the most common toolpaths we use. So usually we're going to take parts like this and we end up with a bunch of holes everywhere and then we got to cut it out. So usually the first thing we want to do is get the holes done first, because if we cut it out first then we can make a mess of things. So we're going to do it with a bore right here. Um, and so you're going to open up this screen. So this first tab here, we're going to go to select, and we'll select the teal tube flute fishtail upcut. That's the one we use most commonly, unless we're doing HTTP or whatever. This is pretty much the one we work to death. Um, so you can see it comes in and it changes all the speeds and feeds. And we should really go through the library, update all the speeds and feeds, but yeah, I just haven't done it yet. We'll get there though. For the bore, the one that really matters the most is our ramp feed rate, because it's essentially going to be in a ramp, like ramping down the bore the whole time. So we can change that to like 200 millimeters per minute. That's good there. So we can come in, we'll just select some geometries here. So these are all small, like basically like under 3/8 of an inch. There's a larger one here. We'll take care of that with a contour. We'll talk about that in a second. So we'll see we got those there. Heights, whole bottom, we always do whole bottom minus 0.5 millimeters. Just make sure we're all the way through because our table's not entirely leveled yet. Another thing, we'll get there eventually. Direction, we want to do conventional because it's soft material. We almost always want to do conventional. Yeah, we could talk about that later if you want. And then let's see, our pitch. So 1 millimeter pitch is pretty high, so let's make it 0.3 millimeters. That's better there. So we kind of look at it, and it's got a fairly tight helical to it. Yes, that would be a decent bore. So we can go through and do all those bores. The next one we'll do would be a 2D contour to cut the part out. So with this one, kind of the same thing. We already have the bit in here. We would go in and select that. It's just that this time we'll make our cutting feed rate 1,000. That's good. Let's make our ramp feed rate also 1,000, because what we're going to do is do a ramp on the contour as well, just to kind of speed things up. So you can come in, select the geometries you want. I always just select the back one, like near the table, and yeah, kind of again we can go to select the heights. We can do bottom height and then minus 0.3 millimeters, just to make sure we're all the way through the part. Passes, again, we'll switch to conventional, and then we'll come in here and go to leads and transitions, turn these off, and we'll go to ramp, and we'll change the maximum ramp step down of like 0.8 millimeters. That's kind of like about the maximum. I'm okay pushing it, and so that's okay there. Yeah, so that's pretty good. With this, if we look at the side here, this ramp profile is starting like way above the part. So on larger parts, it just takes an eternity to get there. So that we would hide that. Where is that? In here. So ramp clearance 0.3 millimeters is fine. And then one more thing we were going to talk about was this hole here, and the reason we didn't do it on a bore. We didn't do a bore because there's going to be a little disc that's stuck in here after that bore, and we don't want it taken off in outer space and break and stuff. So we can select that contour as well. Then we'll also just come in here to tabs, and just throw. I prefer to do tabs at points. We'll just throw a couple tabs in here. Oops. That's good, and I try to make them a little bit higher, 1.2 to 1.5 millimeters. That's okay there. Yeah, so now we have, like say, both of the tool paths that we want. We did the bore, we did the contour. Next thing we're going to do is go to post-process, and then we could, name it whatever we want and save it and send it to easel.